Do you recognize that exponential growth and decay formula right there? Say yes. Yes, I do. Yeah. No? All right. So this is key for everything you're going to do today. Yesterday we graphed b to the x, right, with all kinds of transformations on it. But it felt like you guys were pretty successful with it. I didn't hear a lot of questions, so figured you guys were pretty dialed in. What's important to remember on this is this list of information over here. Okay? If you know this, then you can do any story problem that they're going to present you today. So this guy is the amount after time. And the one that will be presented frequently in your story problems is this one. The initial amount or the amount in the beginning. And sometimes they like to trick you and say, no time has passed at time 0. Okay, so that's A. And then B, that's your rate. It's all listed right there, but I sure like to make it obvious. And that's the amount of time that's in question in your story problem. They'll have a couple of different kinds today. But as long as you have this in front of you, you'll be fine. So, a city has a population of 390,000 people. What's that one? Has a population. A. Suppose that each year the population grows by 8%. What's that? B. Almost. It's almost B. We're going to talk about that in just a second. So almost B. What will the population be after 13 years? What's this one? X. Because that's our time, right? So look back up here, and there's kind of a key phrase right there. It says your rate of growth or decay, but relate it to 100%. So if I've got 390,000 people, I'm going to have 8% on top of that, right? I'll have all of the 390% more plus, did I say 390%? I'll have all of the 390,000 plus 8% more. So the way we look at that, we've got 100% of what we had plus 8%. So what is our rate? 108. Now we don't type percents into our calculators, so we're going to call our B is going to be 1.08. So now let's set it up and we'll have some calculator work. So amount after time, I'm looking up here. Amount in the beginning was 390,000. Our B is 1.08, and we're going to raise that to how many years? 13. So grab your calculator. Let's make sure we can all get the same answer. Wow, that's some serious growth. Shout out what you've got. Anyone going to be brave? All right, we got million, 60,653. I'm going to go ahead and round down to the nearest person since it was 0.2. Yeah, it was 0.253. All right. How bad was that?
No, it's pretty bad.
Was it pretty rough?
It's the hardest thing deciding if it's growth or decay.
Tell me why we knew this one was growth.
Population
grows.
Right.
Yeah.
So let's look at the next one. A laptop computer is purchased for $2,300. After each year, the resale value decreases. So, Paige, in answer to your question, it's going to be pretty obvious for the most part, okay? So it decreases by 35%. What will the resale value be after 4 years? 2,300 is what? Our amount in the beginning, our A, our initial value. 35%. It's almost our B. What do we have to do if we're decreasing? Yeah. So 100 minus 35 is 65%. So our B is, move the decimal twice, 0.65. And what's this for? The X. So Y equals 2,300. B is 0.65 raised to the power of 4. So where this is dollars and cents, right? Your homework will tell you what to round to, but because this is dollars and cents, I'm going to say it was $410.56. Last one. It has a lot more words for you to dig through, but it just even wants you to come up with the equation. It's not even asking us to solve anything. So help me dig through there. There was a sample. There was a sample of 300 milligrams. What's that one?
Initial value.
All right, there's our A. Of a radioactive substance to start a study. Since then, the sample has decayed by 9.4% each year. Decay means we're going to have negative, right? So 100 minus 9.4. Let T be the number of years since the start of the study. So this feels weird, but that's our X. Let Y be the mass of the sample in milligrams. So this is our amount after time. Our Y is just our Y. So we're relating Y and T. That's fancy for saying Y equals, follow that formula up above. What was your amount in the beginning?
8. No, 300.
300. Haha. What is our rate if we're decaying at 9.4%? 90.6. So 90.6%. So boom, boom. 0.906 raised to the T. Then you could use that equation. Say it asked you how much of the sample is left in 20 years, 100 years. You can plug it in for T and evaluate it for any time frame that they give you. Feel good about that? Okay. That is it.